Hi everyone and welcome back to my YouTube channel. And in this video, we're going to show that how can you make one deepfake video using Python and Mediapipe. So last 2 years ago, I uploaded one video on my YouTube channel based on deepfake. But this video having some problem, you need to run it in real time. And also, you need to run the code on the Google Column. So which one is not suitable and take much more amount of time in order to run the code. But now, in this day, I am just making this code more suitable using Python and the most popular library that's called Mediapipe. I searched on Google and found this following website, and I follow this website. I am able to make the full source code using Python and Mediapipe. So in this blog, they actually use here the oldest Python library that's called the Delip. So which one is not supported in the newer version of Python? Also, the performance of the Delip library is not so good as compared to the Mediapipe. And also you're having some problem of the frame per second error. But I follow the step, the 8 step that they are following. So I just actually following the step, and based on the step, I am able to make the full source code using Mediapipe. Now you're going to see that how can we implement it in Python. Now let's go on the VS Code. So before going on the VS Code, let's have a coffee. Oh, now fine, let's go. So this is the complete source code. I actually do it before. So in order to run the code, you need to do some installation. So first you need Opencv, then you need NumPy, and you also need the Mediapipe. And make sure that Python is installed on your system. So in order to install that, this library, just you need to open your command prompt and type here pip install, and the library name is called Opencv Python. And another library name is called the NumPy, and NumPy is already installed when you actually install the Opencv also. And another one is called the Mediapipe. Just you need to install those library in order to run this whole source code, right? So I'm not going to install it here because it's already installed in my system. So I'm going to click here to close that. Okay, well, so you can see here I create here some functions, and based on the functions we are going to actually do the face swap, or you can say the deepfake. So our first step is nothing but take 2 images, but in this case we are going to do in real time. So that's why we're going to first take 1 images as a source images, and the destination one we are going to take it as a real-time camera. So for that we need to also create here one camera. So if you don't know how to create one camera, you can also follow my Python crash course for absolute beginner, because in this course we are going to do 5 projects, and also inside this 5 project I am also show that how can you create on camera. So this is the basics of Opencv. How can you create a camera? This is like on Hello World. So now the step number 2 is nothing but detecting the landmark point. So how can we find the landmark point? So we are going to find the landmark point using the Mediapipe. So if I go on the Mediapipe documentation, so this is the Mediapipe official documentation. If I go down, you can see here some machine learning solution in Mediapipe, and this solution called the face mesh that is basically needed in order to detect the face landmark. I'm going to click here, and what I'm going to do here, I'm just going to copy the code in order to test it out that is really working. So this is the code for that. I'm just going to copy this code here on my clipboard, and I'm going to create a new Python file. So now what I'm going to do here, I'm going to create a new Python file in order to test the Mediapipe code. So I'm going to just pass the code here. So here is the 2 code actually available, one for static images and another one is for webcam. I'm just going to remove this code for static images, and I'm going to just save it and run the code from here. And now you can see here it opened webcam and also detect my face landmark. So there is nothing but 468 landmark. So we need to just copy this face landmark, and based on the landmark we need to do the triangulations. You can see here some triangular is actually appear on here. We need to just triangle them, right? We need to just triangle them, and based on triangulation we are going to replace the face, and it's called the DeepFace swap. Now our step number 2 is done. Now step number 3 is called the triangulations, right? So if I see the code, if I go down, you can see here first we are going to take 2 images. So this is the for destinations and this is for source. See, we take the images of the source images, we import here the cb2, we import NumPy, then we also add here the width and the height of our screen, and we also create here one camera using cb2.video capture. We are going to just create this camera object, and you can see a video writer. If you're trying to run the code, it will actually generate here one video for that. And you also set the width and the height should be the 640 and the 480. And as a source image, you're going to take the image of the Elon Musk. You can see 2 images actually inside my directory. One is the image for Elon Musk and second one for Tony Stark, I mean Iron Man. right? So now what I'm gonna do here, first step is nothing but take the images. Okay, so this is the destinations, and now we need to generate the source code. That means source images. So this is the code for source images, but in the source images you need to actually do this process. So first you take the destination images, and after taking the destination images, we are going to convert the destination image into BGR to grayscale, because OpenCV did the images in the BGR format. And after making that in a BGR format, we are going to create here one frame with black screen. Why black screen? If you see down here, if you see this screen, and you can see here one face is appeared and all the screen is getting converted into black. So that's why we are going to just create here one empty screen using this np.0likes. And using this 0 likes, we're going to just create here one black images. Now inside the black images, we're going to just put our face. That is really the landmark is actually detected. Now we're going to call this get landmark point functions from here. So if I go down, no, go up, you can see here we have a function that's called def get landmark point. So you can see here it will create here one face mesh solution. If I go on this test.py code, you can also see here the same code is available on here, right? Just I'm going to use here. So we are going to actually detect the face. If there is no landmark, so the system will actually exit from here, right? So you can also remove this line if the camera is not finding any face, it will actually automatically give you the error. That means there is no face for landmark. Then it will exit from the system. Now what I'm going to do here, we have I already told that we have the 468 landmark. Now based on the landmark, just you need to crop the face, right? We just need to crop the face of each data point. Then we are going to take each data point and we are going to store it inside one array. No, it's called a list in Python. Then we are going to just return it. So this function, this get landmark point, it actually return me as a landmark of point list, right? Now the step number 2, it's called the triangulations. So this is called the triangulation. But before doing the triangulations, we need to also do the convex hull, right? We need to do the convex hull. Then we need to also convert our destination image into the NumPy array. Then we need to do the same thing. We need to do the same thing with the source images also, right? I think you need to do it in the later on. Now we're going to take the destination images shape and the images height and also the channels. Channels mean this is one RGB image or a grayscale image. Now we're going to create a new face using this np.zeros and based on the width, height and the channels. Now we're going to just replace this width, height, the channels with the new faces, right? So this is the step number 2. Now the step number is called the triangulations. So if I go up, you can see here, this is called the stack the NumPy index array. So it's right now not. When you actually stack the triangulations, then we need to wrap this triangulation, then you can actually use this one, right? So don't worry about the code. I'll just put this code in the description. You can just go ahead and download it. But there should be a password, and password is nothing but DeepFake23, right? Now this is the code for get the triangulation. So if I run this code again, this test.py, then you can see here on the face landmark, there is some triangulations, right? You can see here some triangles appear on here, right? This is called triangular. Now we need to do this triangulation to extract the triangle from here. Now based on triangle, you're going to wrap the faces of the source images also, right? So now if I go here, so this is the code for get triangles. Okay, so this code is actually help us to get a triangle for each data point. Okay, and after getting after getting all the triangles, then we can do the triangulations. Okay, we can do these triangulations. So this is the code for triangulations. So it will actually return me as some point, some crop triangle, and also crop triangles marks. That's mean actually give here some crop triangle marks, and these marks, then later on, you're going to wrap these marks using the red affine in Opencv. Now, if I go down here, you can see here, we need to get the crop triangles, also the crop triangle marks from the source images. So where is the source images? You can see here, this is the code for source images. That's mean we actually do it in destination images. Now we need to do the same thing in also the source images. So you can see here, get landmark points, we need to convert it into the NumPy array. Then we need to do the convex hull. Then we are going to use here the fill convex pulley and also get a triangle. Now after getting the triangle, then we can do the triangulation, right? So our destination image is also ready, our source image is also ready. So now what we're going to do here, we are going to get the indexed triangular from our triangulations, from our what is called the get triangle functions. So inside this function, you can see here index triangular, and inside this index triangulation triangles, it have all the data point about the index triangular, right? So you can see this function is help us to draw the triangulations, and after doing the triangulation of the source images and also destination images, now we have to make it wrap affine, or you can say wrap triangular. Now based on the images, we are going to do that wrap triangular. So we need to also do it in our source images also. So we do the wrap triangle of the source images and also destination images. Now we need to add the faces, a piece of faces with the new faces, right? New face. So you can see a new face with the rectangular that we actually extract from the images, from the source images. Now we are going to swap the new faces with the destination images, right? So if I go up, you can see here, this is the code for ref triangle. Is using here just ref affine, and you can see you actually get the affine transformations. So it will actually help us to give here some perspective value. So when you are working with auth here, it will actually help you to get the text from the book or the letter. Now this is the code for actually adding the piece of new pages. Then this is the final one. It actually use this one same operations and use the b2sn, and after that it will actually do the CMLS clone of the destination images and the source images. And finally, what I'm going to do here, we are going to add here one median blur so that we can remove the noise from that. And after that, we need to also see the source image shape, and based on the shape, we are going to actually give here the source images. That is source images, that's mean this Elon Musk images, and new faces. The new face is coming from here, and also you're going to rate in the on a video format. And this is the video 4cc code. If I go up, you can see here result 1 equal to cb2.video writer, and to give here on video path, and also give here the video 4cc code. So this is the 4cc code. You have to give here the fps, that's called frame per second. You can make it 25, okay? And you can see the weight and the height of your video. Then if I go down here, and you can see here, we just actually add here the cb2 show so that we can show it. And after that, we actually give here one keyboard binding functions. So when the user is a press key from the keyboard, it will automatically back the loop. So don't worry about the code. I'll just put a code on the description of the GitHub link. Don't worry on that. So, but don't use it in illegal tasks, because this is the video for educational purpose. So now what I'm going to do here, I'm going to open my own mobile phone, and I'm going to just use my own mobile phone camera. So for that, I'm going to use here the Droid Cam. So well, my Droid Cam is right on. Now I'm going to run the code here. So well, what I'm going to do here, I'm just going to run the code by clicking this button, and it will open the webcam on my mobile phone, and you can see how cool is it. So this is the new face, okay, the black screen, and you can see here this is called result, and these are our source images. You can also replace the source images also. See how cool is it, and the resolution of my mobile phone camera is okay, fine, that's good. So see how cool is it. So let's use here another images of Tony Abstract. So let's use that. Let's use here Tony 1 dot. So this is the another extension type images that's called JFIF. So it is another extension of the images. So if I run the code here again and see the output, wow, that's C. So that's called Tony Abstract, right? Okay, that's really cool. Fine. Now it looks called Tony Abstract. Fine, cool. So I have also one video. Okay, we can also test it out here. So let's test it out also. So you can also use here the external video from that. So this is the video just I am going to use here, deepfake.mp4. I'm just actually recording this video using my DSLR camera, and now I'm going to just use it. So let's use it here. So instead of using the one, you can give here your video path. So let's say deepfake.mp4, right? It will actually it will actually call this video, and it will show it on my screen. So if you see it just white, you can see this is my video, and this is my source images. This is my new face, right? See how cool is it? It's really working fine, and I am looking like Tony Stark. I mean Robert Downey Jr., my favorite character, Iron Man. So see how cool is it? That is really fine. and the FPS is very better is compared to the DLib, right? So you can see just to white, I just give here the FPS as 25. If I go on this file name.abi, if I go on the folder structure, so if I go on the directory, you can also see the video is actually saved as file name.abi. So you can see one file is generated that's called file name.abi. You can also see it. The FPS is nothing but 25. How cool is it? It's really cool. So using that, you can build your own deepfake, but don't use it as the illegal purpose. So thanks for watching this full tutorial. Hope you enjoyed this tutorial, and make sure to subscribe to channels and also hit the bell icon and also give a like. So I'll be back with another tutorial. So till then, take care and bye bye.